Our topic of mechanics, vertical projectile motion, is going to be broken into two parts. This part that I'm doing now is still part of lesson 1, where we are going to look at different questions of how to solve VPM problems. The second part of vertical projectile motion will be comprised of looking at vertical projectile motion graphs. So we need to be comfortable with our calculations because we are going to use these calculations to sketch graphs or either be given a graph and we are able to then read the graph and find some of the concepts and quantities we spoke about in this part of the lesson 1. Now we are going to start our practice by looking at question 1. Now in question 1 they say here that a steel ball is projected vertically upwards with an initial velocity of 2 meters per second from the reference point. Now, I think already you know that we use the academic constitution where we start with the first rule in that constitution that says I for interpretation. So now I'm doing question 1 here and I'm doing interpretation. So as part of my interpretation, I will start first by choosing direction, which in this case I'll say take upwards as positive. This means any vector that goes in the upward direction will be positive, and automatically the vector that goes down should be negative. Now we are given here an initial velocity of 2 meters per second. So our initial velocity will be a positive 2 meters per second because it goes up is the velocity, the initial velocity at which the ball is actually thrown upwards. But now they say they throw this from the reference point. So sometimes, as we do our interpretation, it's important to draw diagrams. So we have this ball here. It moves with this initial velocity. Now the trajectory that will be formed here would be such that the ball will go up, reach a maximum height here, and comes down to where it started. Now the whole idea of the reference point here is that at this point, where the ball started, we say is the reference point. This is the reference point. Now the reference point means the origin, or a point where the position, displacement, or even distance is 0. So it's a position where we have 0 meters here in terms of our distance or position. In other words, here that's where we start reading our positions. So it started at the position of 0. Because that's where it was thrown. Now they say here, assume that there is no air resistance, right? There's no air resistance, and the ball actually returns to the starting position. So the ball comes back to the starting position. It moves from 0 position, it goes up, and then comes back to 0 position, right? It comes back where it started at the origin, at the reference point. Now, we also know that when the ball reaches this maximum point here, we are actually going to have a velocity. I'll call this final velocity of 0 meters per second. So our final velocity there would be 0 meters per second. Now, this is the velocity at the maximum position or maximum height, right? And it's going to be final because this is the initial velocity and that should be the final velocity. And the other thing that, oftentimes in projectile, they won't give you is the fact that we all know that there is the acceleration due to gravity and is given by g. And we know that g is going to be a 9.8 meters per second squared. Now, very important, because this acceleration goes in the same direction as the force of gravity, which is always vertically downwards. Remember, the two are directly proportional and therefore they go in the same direction. It then means our acceleration should be negative because it's pointing downwards. It's a vector that points downward. And we said vectors that go up should be positive. So it depends on how you have chosen direction. If we chose down as positive, then it will be positive. But in this case, we chose upwards as positive, meaning down should be negative. Now, The other thing that I will do, well, I'm done with interpreting my question, so I'll move to the next step, or the second rule of the academic constitution, which is the C rule. The C rule says we need to classify the question, C for classification. Now, in this rule, we link this given information to the topic that we know in physics. So for me, so we try to see where does this information fit? What topic is this? What can we say is the best topic to use here, or that is applicable? When I look at this problem, for me, I mean, words such as projected vertically upwards already gives me hints that we're dealing with vertical projectile motion, as we have described it in our previous lesson, in this part of the lesson, part 1 of this lesson. And we also have information such as no air resistance. I mean, this confirms as well that is a projectile, because a projectile would be an object that moves in the air, right? But in the absence of air resistance or external forces, so there are no any other forces. The only force present is that of gravity. So this tells me that I'll classify this problem as vertical projectile motion problem. So this means I'll use equations of motion basically when we say it's a projectile motion problem. And already I can see here that I have 3 quantities, and we know that if we are given 3 quantities, we can use any of our equations to be asked any of the other quantities. Maybe they'll ask me time here or displacement, because I can see I don't have any of those in this given ones. And on the equations, I know that those are the other ones that I have. Maybe I could be asked as well, height at any point or something like that. Now, the first question says to us, so basically we are done with classification. We are now going to the A means answer the questions. So the first question that we're going to answer is 1.1, that says describe the trajectory of the ball. Remember, we spoke about trajectory, and we said that trajectory is the path that is created by the projectile, the path that the projectile will follow. Now, in this case, you can see that our projectile will go vertically upwards, and comes down. So it will give us a straight line that goes up and down, right? That's how you'll describe the trajectory. So, here we said is a linear line, meaning a straight line, up and down, right? So that means our projectile will go up and stops for an instant and comes down again. It's a straight line like this, our trajectory. And we said when we draw them for solving problems, we'll draw it as if it's a curved path, but this is not the true path. It is just for us to simplify and understand the problem, because we don't study projectiles that are curving. We study vertical projectile motion. Very, very important to understand that. The second question, so the other thing after answering the question is navigation. So with navigation, really, you look at your answer and see that there are no errors, or if it makes sense as well. So this is a simple, straightforward question that will be marked out of 1, and you can see everything is right hand really well there. So this should be 1 mark, not 2 marks. Now the second question, 1.2, says describe the motion of the ball. Now when we say describe the motion of the ball, what basically we want here is information that relates to your kinematic concepts. So you need to speak about acceleration, velocity, time, and the displacement of the ball. You have to describe everything that happens in there. And we know that in this motion, actually we just described it here when we were doing our interpretation of the problem, to say it will have an initial velocity that is actually decreasing as it goes up at a constant rate, at a constant acceleration until the maximum position, where actually it stops for an instant at the velocity 0, and it will return, it will change direction and actually start increasing its velocity at a constant rate again, at a constant acceleration, until it comes back to the starting position. So that's basically how you should describe that, and it is out of 4 marks. So here we're saying here that the steel ball moves up with a positive velocity, slowing down at a constant acceleration until the maximum height. So now all this will give you 1 mark, because basically saying it's going up, slowing down at a constant rate. Now they have attached direction here because already we chose up as positive, All right, so just to put in the meat when you do your description there. And the important things are that it slows down at a constant acceleration, really, because it slows down at a rate of 9.8 until it reaches the maximum height. Now, the other point will come, or mark will come, from the fact that you'll say at the maximum height, it stops for an instant, right? Very important to say it stops. Now the ball moves down with a negative direction. It will change direction and move down in the negative direction, because I mean it's not going now in the positive direction anymore. But this case it's speeding up until it reaches the origin, the reference point. Remember, the origin we said is the reference point. And the last mark would come from the fact that you'll say there's time symmetry here. The time that it takes to go up is the same as the time that it takes to go down. You know, the time to get here is the same as the time to move from there and get there. That is 4 marks. Basically, this is a summary of what happens in vertical projectile motion. It's a very special type of motion in that there's no air resistance, and as a result a lot of things become the way they are here. We see time symmetry, we see a constant acceleration. Remember, if we were to have air resistance here, maybe the air is blowing like that, this thing would have moved maybe something like that. It will give you a random motion. But because there's no air resistance, it has to then move perfectly up and come down again. Hence we say it's a very special type of motion. Now again, you'll navigate this answer and see that it makes sense. You'd see that it really makes sense. If you check it, everything is okay. So that is the last rule of navigation. We go back now to answer. When we go to question 1.3, they say here that what is the maximum displacement of the ball above the reference point? Now what they're asking us here is that what is this maximum position from here to this top part here? What is this position change in y? What is this? Because remember, this will be the maximum displacement, right? This is how far it will be displaced before it comes back down here. So what is this maximum displacement of the ball? Now to answer this question, which is 1.3, we are going to use our equations of motion, and we can see here that the equation final velocity squared is equals to initial velocity squared plus twice the acceleration due to gravity times the displacement. In this case, it will be this maximum displacement here, right? Now, I'm using this equation because I have the initial velocity, I have the final velocity. So I have the initial velocity here and I have the final velocity there, right? And we also know the acceleration that is accelerating with as it goes up there. Now that will allow me to find this height here, because I'm using the velocity from here to here, right? And the acceleration, of course, is always there, whether it goes down or up, is always there. Now from this point on, I'll then substitute my given information to say my final velocity is at the maximum height is 0 squared, and my initial velocity is really 2 squared plus twice the acceleration, which is going to be negative 9.8, because it's going down and down. We chose it as negative, and we are looking for the change in y. Now from here, this question becomes really boring, because we're just going to press our calculator, or we can even solve it in before we go to our calculator, but simplify a little bit. Now if you look at this, is going to give us a 4. So we're going to have a 4 because a 2 squared is a 4. I'm going to take this 4 this side, so that I'm going to have a negative 4 is equal to, and if you say 2 times 9.8, you should get the negative 19.6 times change in y. And you know, at this stage it means I'm going to divide both sides by the negative 19.6, so that this side it cancels and I'm left only with change in y. Now on my calculator, it means that now I'm going to press the negative 4 divide by negative 19.6, and this gives me a displacement of 0.20 meters. Now because my displacement came out as a positive number, it then means this ball is actually displaced upwards, is going upwards. it is at a displacement that is in the positive direction. Now, because we are done answering this calculation question, we are going to do our rule of navigation where we see if this answer makes sense, right? And when you look at this, we calculated the correct thing, the change in y, and we have 0.2 meters, which is a positive answer. And you can see that if we say up, this thing is displaced in the upward direction, so it is going in the correct direction. That assures us that we're going in the right direction, so the direction also makes sense. The value here seems pretty much small, but it makes sense because this thing is only moving with initial velocity of 2 meters per second. Remember I said to you that if the velocity here actually will determine how far this object will go. If we throw it with a high velocity, it will go to a greater maximum position. If we throw it with a relatively small velocity like here, it will then go to a smaller displacement or maximum height. So that looks good to me, 0.2, given that it's actually going up with 2 meters per second. Now that I'm done navigating this answer, I'll then go answer the next question. So we go again to answer. We look at 1.4. Now in question 1.4, they say to us, how long is the ball in motion before returning to its starting position? Okay, before I answer this question, I just want to look at how this is going to be marked out of 4. Very important to look at how we're getting marked. They give you a mark for writing the correct formula, and the interesting thing is that these formulas are there in the formula sheet. You can literally go check them if you're not sure of them and copy it the way it is and substitute from there. They give you a mark for the correct substitution, and they'll give you 2 marks for the final answer. So the fact that you wrote the number and the direction, very important. So to answer the next question, we're looking for the change in time, but very important, the time that we're looking for is the time before it returns to the starting point. So in other words, it's the time that it takes for it to be in the air, for it to move actually up and come down. So the time that it comes up until here, right before it will hit that starting position and stop. Now, if you look at this time, there's various ways of doing it, but one of the first ways maybe is to say that the initial position of the ball was 0 meters, right? Meaning it started here at the position of 0 because it was at the reference point. Then it returns again, the final position to be 0 meters. It returns again to the same position it started with, meaning the final position is also going to be 0. So this means this ball was not displaced. If you look at the change in y, remember change in y will be y final minus y initial. We're going to have a 0 minus a 0, which is just a 0 meters. This ball was not displaced. It actually moved from 0 and came back to 0. So the displacement is 0. Now with that knowledge, I can then come here and solve this problem using the equation that the displacement is actually equals to the initial velocity times time plus 1 over 2 times the acceleration due to gravity and time squared. Now here we know our initial velocity, that it's 2, and we are looking for the time, and we also know that here we have negative 9.8 and we are looking for the time. And remember, this side we said the displacement is 0 here because it was not displaced. It came from the same position it started from. So to solve this, if you look at this equation, for me it looks like a quadratic equation, a binomial, right? Where I have a common factor of t here. So this means I can say 0 is equals to now I'm going to take the t out so that I'm left with a 2 here, and here we're going to have a negative, actually negative 4.9. If you take half of 9.8, it will give you negative 4.9, and we are going to multiply this by a t. Now remember, if I multiply this, I get this back, if I multiply that, I'll have, the 4.9, which is half times that, and this will be a t squared. That's what I'm saying. I see, a quadratic equation that I can factorize here. Now we know from mathematics that this would either mean that it would imply that the change in t is equals to 0, or the change in t is equals to okay, maybe not the change in t, but in fact here, I want to write this in full. The 2 minus 4.9 times change in t will actually be 0. Right, now this would then mean we can simplify this side further to then take the 2 to this side, so that we now have negative 4.9 times change in t to be equals to negative 2. And from this stage, I can just divide both sides by the negative 4.9, so that I'm having negative 2 divided by negative 4.9. And this gives me a total time that will give me a 0.41 seconds. Now we have two times that we got here. Obviously, the 0 would mean that it's when we started throwing the ball. You start at the change in t squares to 0. But the 0.41, it will be when it went up and came down here. So the time that we're looking for would be this one, right? Not this, because this is when it is at the starting position. Now, to look at how this is going to be marked, because it is marked out of 3. So 1 mark for writing the correct formula, or using the correct formula, and the other mark for substitution, and they give you the mark for finding the final time. Now, there is another way in which this question can be solved. That is to say that you can actually use this equation here to say the final velocity is equal to the initial velocity times the acceleration. But check what we do here. You plus the acceleration times the change in time it takes to go up. In other words, we are saying here that we use the final velocity here, which is 0, this final velocity here, which is 0, and we're saying it's equals to the initial velocity, the 2, right? The initial velocity is the 2, and the acceleration is 9.8 because we chose that as 9.8. Because I've used this velocity and this velocity, it means the time that I'm going to get is from here to here, right? And this time would mean is the time up, right? That's why here we write it as time up, is the time that it takes to go up. And we get that time really as 0.2 meters per second, 0.2 seconds, sorry. But remember, we're looking for the time that it takes to go up and come down again. That's why here now, for the total time, we're going to multiply this time by a 2, and we then get the 0.4. This method is inspired by the time symmetry that we have in vertical projectile motion. Remember, we said that two things are symmetrical here. The time is symmetrical, and the speed. The speed of the projectile when it goes up is the same as the speed of the projectile when it goes down at every point or position of its motion. So this is another way in which you can really solve this problem. We are going to look at question 2 now. So in question 2, they say here that a metal ball is dropped vertically downward, and it takes 2 seconds to strike the ground. Ignore a resistance. Now, as I'm reading this question, it is part of interpretation to read the question. Now, I'm going to break this question down here by actually writing down my given information. So this is question 2. I'll say that here And what I will do is that I'll then now in this case say take down as positive, right? So I'm choosing any vector that goes down to be positive. And here I'm given the time to be 2 seconds. Now what's happening here is that we're saying we have a ball here that is dropped. And obviously we know that when this ball is dropped, it will make a trajectory that goes down like that up until some point here. So the ball will end up being somewhere here. Now we say the time that it takes to move from here to here is actually 2 seconds. And we know that there is always the acceleration due to gravity given by 9.8 meters per second squared. So this is 9.8 meters per second squared. Now notice that now here my acceleration becomes positive because I chose down as positive. So it's going in the positive direction. This vector is going in the downwards direction. The other thing that is very important and you're not going to be told is that the initial velocity here, the velocity at which it starts moving at is 0 meters per second because they said that it is dropped. Remember, we discussed this really carefully in the lesson to say when an object is dropped, the initial velocity is automatically 0 meters per second. Now, we say ignore air resistance. This already tells us that it is free fall motion, right? It's a motion in which there are no external forces. The only force present is that due to gravity. Now, this actually already puts me in a position where I want to classify this problem. And, you know, by looking at all the information that I have, this fits well into vertical projectile motion. It's an object that moves vertically, all right? Under free fall, there's no air resistance. The only force present is that due to gravity, hence we have the acceleration here, g. So all this information feeds well into projectile motion. Now that means I'm ready to then answer this question. The questions, question 1, 2.1 says to us, define the term free fall. Now we said that free fall is the motion in which the projectile moves under the influence of gravitational force. Only. And this will give you 2 marks. So if you write everything correctly there, they give you 2 marks. Now, after you answered the question, you can navigate the answer, meaning you look if there's no mistakes or any errors. Now, for this type of a question, you look at the spelling errors and if your sentence makes sense. We're saying here that the motion in which the projectile moves under the influence of gravitational force only. That looks correct to me. Now 2.2, they say calculate the displacement of the ball. To get the displacement of the ball, we are actually looking at the change in y. We want the displacement, so we want to know when it moves from here to here, what is the displacement. Already we can see that it is displaced in the positive direction because our vector for displacement is going in the positive direction. It's moving from the top to the bottom. We expect a positive answer. That's what I'm trying to say. So when we navigate the answer that we're going to get here, we expect it to come out as a positive answer. Now, to answer this type of a problem, you can see already that I have 3 quantities here. I have the VI, I have the change in T, I also have 9.8. This for me calls for this equation where we say change in Y is equals to initial velocity times time plus half the acceleration due to gravity times time squared. I mean, all these quantities are there. It is possible to also use other equations. They will work as well. You just have to know what you are doing, right? Now here our initial velocity is going to be 0, and the time we said is 2 seconds plus 1 over 2 times negative 9.8. Now look at the mistake that I'm doing here. This is not negative, because remember in this case we chose down as positive. Our 9.8 is actually positive. And then we have here the 2 seconds squared. Now to determine this, we can use a calculator, where we will say we have 0.5 times 9.8 times the 2 squared. Now notice that on the calculator I don't include this because really it's 0. All right, and we're going to end up having a displacement of 19.6 meters. Now already I expected this type of an answer. In terms of navigation, I can see that my answer looks correct because it came out positive and is the vector that we actually expected. Right, so the final answer here, maybe as part of navigation, to make sure that I've answered and written everything, I would then have to also attach direction to say downwards, because remember the question was asking that we calculate the displacement, which is a vector. You have to put direction as well. Now this will be marked out of 4 as well, because 1 mark will be the correct equation, the substitution, the value, and the direction. Now question 2.3, we are going back to answering the questions from our academic constitution. So here we're answering the question again. They are saying here that calculate the velocity of the ball just before it strikes the ground. So we are saying here that what is the velocity of this ball here just before it strikes the ground, when it's about to hit the ground there, because it will hit the ground with some velocity. Now you'll see that this velocity at the bottom here will be the final velocity, because we have the initial velocity here and this has to be the final velocity. Now this question becomes open to a lot of equations really, because we have here 1, 2, 3 quantities that we can use, and we also have this one that we calculated from the previous question. So there's about 4 quantities. That means I can use almost all of the equations that we have to find well, I can use 3 of the equations to find the final velocity, because the other equation doesn't have the final velocity. So now to find this velocity, I can really use this equation here to say the final velocity is equals to the initial velocity plus the acceleration times change in time, because I know that when I substitute, I'm looking for the final velocity, and the initial velocity is 0 because the ball is dropped, and here we're going to have a 9.8, and it takes 2 seconds to get to the ground. And you know, this becomes a really nice problem to deal with, because we end up having a velocity of 19.6 meters per second. And because it's the velocity, we'll say it goes downwards. We'll attach direction to it, because we asked to calculate actually the velocity. Now this answer, if we navigate to see if it makes sense, you can see that actually the velocity will be a vector that goes in the positive direction, so it makes sense. Yeah, and the value looks good as well, because remember we are expecting this projectile to actually be speeding up as it goes down. Yeah, it should be increasing in velocity because it started at 0. Remember that the force of gravity, which is pulling the ball downwards, is in the same direction as the motion of the ball, so it will make it to speed up as it goes down. So it's possible that it can reach 19.6 meters per second, you know, in the height of 19.6 meters, because that's quite a lengthy distance if you look at it, or displacement if you look at it in that way. So in terms of navigation, our answer makes sense. We are going to do the last question here, question 3, So these questions, if you look at them, they give us different scenarios. These are the three classic situations or problems that you can get in vertical projectile motion. And then from there could be any other problems that emanate from these three, where a ball maybe is bouncing, where you throw two balls, or things like that. There could be a mix of questions from them, but these are the three classic questions. If you understand these ones, you are able to maneuver the other ones that can be given. So as part of interpretation, I'm going to read this problem. It says here that an aluminium ball is thrown vertically downwards at a velocity of 20 meters per second, and it takes 1.5 seconds to hit the surface. Now what we do here is the same question that we did previously, if you're really looking at it in that way. So here I'll choose upwards as positive, just to mix things up. Direction, remember, it depends on you on how you choose it. But if you look at this situation here, we actually have a ball that is thrown. So it is given an initial velocity of 20 meters per second. So this question is the same as the previous question. The only difference is that it doesn't start at zero. This one is thrown, so that it now moves vertically downwards, because it is thrown vertically downward. It gets to that point. Now they say it takes the time that it takes from here to here will be changing t is equals to 1.5 seconds. It takes 1.5 seconds. The other thing that we know is that there will always be the acceleration due to gravity, which is going to be negative 9.8 meters per second squared. Now in this case it's negative because we chose up as positive and it's going down, so it has to be a negative. The other thing they say, in the absence of air friction, right, if there's no air friction, they say calculate the magnitude of the displacement of the ball. Now all this information tells me that we are dealing with a vertical projectile motion, because really if you look at my diagram, I have an object that moves vertically downwards. There is no air resistance. That means it is in free fall, and all those information, they link very well with vertical projectile motion. Now the question requires us to find the magnitude of the displacement. So what we are asked to do here is to find what displacement will it have here, right? And we can see that our displacement should actually be negative, because the vector that will be going down, remember, the ball moves from here to here, it is displaced to this position, so it will have a displacement that goes down. We expect a negative answer, right? But again, the question is requiring us to actually only write the magnitude of the displacement. So that negative answer, we should remove the negative and only report the number, the magnitude, right? Remember, magnitude means size. But it's going to play a major role, that negative, because if you don't get a negative, it means our answer, there's something that we've done wrong. Now to do this question, again, I simply have three quantities here. So that means I can use the equation that says change in y is equals to initial velocity times change in time plus 1/2 the acceleration due to gravity times time. This becomes a very simple substitution problem, where I will say my initial velocity. Now, very important, I've done a mistake here. My initial velocity should be at negative 20, because it's a vector that goes down and we choose up as positive. Very, very, very important to look at that. So this is going to be negative 20, and we say it takes 1.5 seconds. Then here we have a negative 9.8 because it goes down, and we also have 1.5 seconds. Now from here I can use a calculator. So we are going to have negative 20 times 1.5, and here we have a plus 0.5 times the negative 9.8, and we are multiplying this by 1.5 all squared. And this gives us a negative 41.03 meters. Now, because we are looking only for the magnitude, I'm going to take this number here. I'll say therefore the magnitude of the displacement is equal to 41.03 meters. Then I'm not going to write downwards. I can see here it's going downwards because it's actually going in the negative direction, right? Because up is positive, remember. But because they're only looking for the magnitude, I'm going to write the magnitude. So this is more like we have calculated the height that the ball actually covers when it goes down. That's another way of looking at it. And that is part of navigating our answer here. Okay, so now I was just moving because already I assume that you know this academic constitution and you're doing it in your mind. So we answered the question and navigating the answer, and right, to see if the answer makes sense. All right, so our answer pretty much makes sense because if you look at this problem, we started with a velocity of 20 meters per second and we're moving in 1.5 seconds. Now remember, this thing is increasing its velocity as it goes down, so it's possible that it will cover quite a significant amount of displacement. If you look at the previous question, we were starting at 0 and we covered like 19.6. So if we started 20, we'll cover pretty much a bigger displacement compared to the first situation. So that's how you can know that our answer makes sense. Again, 1 mark for the formula, 1 mark for substitution, and 1 mark for the final answer. Now you have to notice that this question is 3 marks, and we used to be marking this type of a question for 4 marks because you'll include direction. So you have to see those differences. When they say the magnitude, then answering that question in that way will be 3 marks. But when they say the displacement or the velocity, when you put direction, they also mark the direction. So very important. And I mean, if you start putting direction here, they'll mark you wrong because you're not answering what they have requested you to answer.